Hello! Hey everybody, it's Shaziz. I'm out here in the Mad Science Laboratory. Got a friend out there, Super B776, that suggested that we name my lab assistant here Sparky. So say hello to Sparky. It's a pretty good name there. Sparky, he's my lab assistant. So what we're working on today is first, I want to introduce a nifty little coil design that I got going on here. This right down here is just a core out of a doggone electric motor. So I took all the windings off of it and just using the laminates all still glued together. The reason why they use them particular styles of deals, when you have the separated laminates in there, it causes the field to collapse faster, and so that's what you want whenever you're going to be messing around with Tesla coils. You want a field that'll collapse, come on and off real quick. Anyway, that's the reason why I use that particular deal for my primary on this coil. Couldn't tell you how many windings and turns I got on there, and it's just that's neither here nor there, because Nikola Tesla was trying to tell everybody what they didn't get was people's under the assumption that it's due to the number of turns per inch, so on. There's even an equation out there for it, but in reality it's actually the surface area, because the electrons actually travel on the outer skin of the copper wire. And so this is my secondary here, this is my primary, and essentially at the top I have a impeller out of a old vacuum sweeper. It's an aluminum impeller. It has a couple hundred turns wrapped on the inside there. I got to get that back down there. A couple hundred turns wrapped on the inside of the impeller right there, and then a crisscross pattern over at the top. And of course you've probably seen this before. This is my, if you've seen my fly-by-wire reactor, this is my little fly-by-wire reactor. And I'll be showing you how it also picks up wireless energy. So what we're going to do here today, something pretty unheard of. I've got my power supply down here. We're going to take the elevator down. See you in a minute, Sparky. We'll be right back. Alrighty then. My power supply to my 12-volt battery that has one dead cell on it is what runs all the rest of these coils that you see throughout the lab. So that's runs a 20 kilovolt oil burner igniter. And so the purpose of this video, because there are apparently some folks that don't think I understand electricity very well. So basically I'm going to ramp it up a hair and give them something to think about. Anyway, what I'm going to do is I'm just going to connect the primary, the secondary coil off of the nifty little coil that I got going on that I don't have a name for just yet. And I'm going to connect it to the positive terminal of this 12-volt car battery, and that's going to be the power source. Just the positive terminal. Okay, taking the elevator back up here. Notice that's my wire there. We're going to go up there, and it's connected into my secondary, which is this one right here on my coil there. Maybe I'll call that one the Sparky coil for Sparky. Okay, essentially what I want to do here is I want to fire this thing up and see if we can stand Sparky's hair up a little bit, and basically show you a couple nifty things. I'm going to turn a light or two off so we can get a better see at what's going on. And I'll just turn one light off, get the glare off there. Okay, we got the glare off. Now, Yeah, that's me falling over stuff in my mad science laboratory. Okay, here we go. We got a energy saver bulb, and we're going to see how powerful this one wire system running off of the positive post of this battery is going to be to energize that coil. Excuse me. Alright, here we go. Look at here. Maybe we're going to have to kill some more light. Let's try this one over here. Leave the little solar light on. Alrighty, there we go, floating in. Yeehaw, see that? Do. Alright, that's a pretty powerful charge going on there for this particular coil. Now, watch this right here. See that? That's a lot of juice. Running off of what is now a 20 kilovolt battery. Let me shut this thing off just for a second and grab a, well, no, I can grab this ground wire over here and see what we can do with that one. This one will blow nothing up, man. Okay, I got a ground wire. Alright. Hopefully this isn't going to shock the crap out of me. Okay, here we go. Do. Look at the power there. Get up here a little higher. Alright, old Shaziz doesn't know much about electricity. That's a pretty good arc with my little ground wire right there. Well, this is a point where I've got to be super careful because I do not want to touch that primary or the secondary on this particular deal. You see it's got a pretty good field going on here. Alrighty, see there's a lot of energy coming in off of that. Notice that my my fly-by-wire reactor is reacting. I'm using this energy saver bulb because there's a buttload of juice, so that's going to be my ground. Notice when I touch different areas that the LEDs will follow me around, and I'm afraid to get my fingers down in there too close to this particular deal because it will pretty much do some damage. There's a lot of juice running through there. Okay, let me turn the light back on for a second now that you see that it's got some power. I don't know if you can still see the plasma with the light on. However, oh, Sparky's hair is standing up. Let me kill this just for a second. Anyway, there's essentially 20,000 volts of electricity running through this car battery with one dead cell in it that I've been using for over, oh shoot, about 2.5 years. Now, what I'm going to do here is, so that I can prove what I'm saying, we'll look at that. Yeah. Uh-oh, over here. Yeah, that is a car battery right there. And keep in mind that this is also running the rest of the coils throughout my lab. Sparky's hair is still standing up. So, that's what I wanted to share with you. No light. Plenty of light. No light. Plenty of light. Yeah. You don't want to stick your tongue on this particular one. It's a lot of juice. Alright, this is just a show and tell video. Trust me when I say that the information is being gathered up and is on the way to show you how to create all this kind of stuff. But once that information is actually in your hands, then it's going to be up to you for your own personal safety. So I always say practice good safety habits whenever you're messing around with high voltage electricity. But you just saw with your own two eyes a 12-volt car battery with thousands of volts running through it. And of course, like I said, Sparky's hair still standing up. Positive terminal, negative terminal. Alrighty then. And it hasn't blew up yet. After 2.5 years, the battery's still good and it hasn't blown up. Also, I'm working on a really good surprise for you that I hope to get done within the next month or so. I'm waiting on some parts to actually do it, but people's been really anxious to get off the grid, and I'm going to build a mini prototype like I always do because it's the cheapest route to go. And I'm going to show you how to get off the grid permanently. And of course, that doesn't mean that's my grand finale, because wait till you see what I'm up to, and when you find out what my grand finale actually is, you're gonna freak. Peace and love, everybody. This is Ziz signing out. I hope you enjoyed this video, and say goodbye to Sparky. He said he loves you too. Alrighty then. Peace out.